This conference will now be recorded.
All right. Shakik, take it away. Well, I don't believe you're sharing your screen anymore. And we cannot hear you.
Yeah, we can't see, we can't hear. Can you stop the recording till he is?
This
Yeah,
conference will now be recorded.
Yeah, we see the cover slide.
thank you.
Okay, the TPM
Shakib, tell me.
2.0 HNT hardening the network. All right, so
Yeah.
I'm under the impression you guys understand what TPM 2.0 is and also UEFI. So we don't have to talk about the fundamentals of these two devices or elements. Just to say that we're using the TPM as a hardware security module, and we're using the UEFI stores to help facilitate our hardening of the network. And of course, this presentation is in pursuant to the OCP section that we are submitting in the OCP document. I suppose it's going to be published sometime later in the year or sometime later.
Shakib, prompt me for the
Yeah,
second slide, next slide, then I will do, right?
got you. Next slide.
Slide number 2.
Yes, topics. So these are the topics we'd like to cover today. We'll start with some functionality overview. Then we'll dive into the administrative key management, following signature verification on boot and patch, reading PCRs for measured boot. We'll dissect initialization, audit log, and alerting. And at the end, we'll briefly go over some takeaways. By the way, my name is pronounced Shaiki, and last name is Johnson. Shaiki Johnson. Next slide. Functionality overview. All right, so the administrative key management is a typical generic UEFI stores manipulation. So the use case for us is to manage the certificates by way of a BIOS GUI interface and also NAS CLI or via APIs. Here we will provision the platform key, KEK, DBDBX, and we will do it in such a way that it can be done automated. It can be automated, and I'll talk about that later in the presentation. And once, of course, we have the certificates and keys, public key infrastructure certificates created in place, we can then use them to facilitate our security measures later on, such as the verification of the signing on boot and patch. And also we will, with the certificate, we will utilize that in our PCR measure boot functionality. So just to give, so the graphic on the side just gives you a, the graphic here just gives you indication of which element is to be used and for which purpose. So for the administrative key management, we will use DP space, but the TPM, we will not use it. Of course, for signing verification, yes, the UEFI space will be used, the TPM, no. And for the measure boot, yes and no, excuse me, depending upon the allowed certificate that the vendor in question, the NAS vendor in question, will use. So if they use the UEFI stores to store their certificate, then yes, the TPM and UEFI will use that. Otherwise, no. The certificate will validate the NAS using the database. Oh, my allergies don't kick in. All right. Next slide. Administrative key management. Administrative key management. To say, okay, so we say UEFI, but the UEFI BIOS GUI, we will provision the authenticated variables, CK, KK, DVDVX space, and we'll talk a little bit more about this in later on the slides. But anyway, this will have to be accessible during the boot process, and must have the ability to manage certificates and keys. This is not the only way we'll do it. We'll do it via CLI or APIs so they can be automated. The NAS itself will have the ability to add keys, append, remove, delete keys using the CLI. And for a cluster, of course, these NAS commands will be able to access the UEFI stores across multiple white boxes, across multiple clusters. And this is, again, a way to automate the process so that we don't have to reload or reboot the box while it is in use in deployment. Next slide. Signature verification of NAS on boot and patch. So when the NAS is to be installed into a box, it comes into the box with its certificate attached. That certificate will match or will have a public key that will match a key that is embedded in a certificate stored in the allowed space. Okay, so initially this will be an out-of-band setup. Initially, where we will provision the UEFI stores, as I just mentioned earlier, by way of the administrative key management process. And then once the NAS comes in to be loaded, it will run its normal UEFI checks and balances to check to see if certificates that was provisioned matches the certificate that came with the NAS. Of course, if they match, the NAS will be installed, and if they don't, and if the disallowed certificate matches the certificate that came with the NAS, and of course that NAS will be considered to have a certificate what is known to be disallowed and a threat actor, and of course it will be rejected. An alarm will be issued, okay, to alert the AT&T OSS folks, but the boot will proceed. So again, this is the difference. We're not using secure boot. Where we were, secure boot will not, it will shut down if it detected a disallowed certificate with a NAS. In our case, we don't want it to shut down because that could be a router which can interrupt the business of one of our clients, and it could be tens of thousands of clients on one cluster. So we want an alarm to be issued. We want to boot to proceed. And this will happen similarly for a patch. Once the NAS is up and running, if that patch fails, the verification, the patch will not be allowed to install, and the router will boot to the previous configuration state and proceed. And of course, an alarm will also be issued in that case. So boot or patch, a similar process will take place.
One question
in terms
I have.
Of the,
Yes,
go ahead.
The second paragraph there mentions installation. This is in the context of boot. So is installation a phase that happens on every boot, or is that a one-time thing?
Yeah, this is a one-time thing. when the white box are being provisioned during the staging process, that the NOS, of course, is out of band. It's not deployed yet, and the NOS will be installed. Now, let's just say you have to power cycle the NOS, the white box, or repurpose it, or take it to a different location. Now you're going to you have to reinstall the NOS. Okay, now we have certificates that will be already stored in the UEFI space, and this security feature and measure can take place.
Okay, so when it says if the keys match there, that's so we're doing that signature verification on every boot, and we will always proceed to boot. But if the signature fails, we'll issue an alarm.
Right. Yeah, the keys match on installation follows. The installation of a NOS. If you're installing a new NOS, an upgrade to a NOS, these are the procedures you'll follow. This is not the staging process. This is after staging.
So if the NOS is not changing, we still do these checks on every boot?
Well, no. No, this is for installation of the NOS. Yeah, you're not necessarily checking.
Right. Okay. So this is just
right. Okay. This installation. There's another way we use with TPM, and I'll talk about that later, where the PCR measured boot. Then we are checking the concatenated hash. Okay, of the configuration of the box, which will include the NOS and the file system and the firmware. But in this case, we're talking about the installation of a NOS or SMU.
Sure, I guess
necessarily.
I just got a little bit confused when it said signature verification on boot. That seemed to imply it was.
Yeah. I know. Yeah. Well, see, in fact, we're trying to get more than one bird with the same stone. Okay. So on boot, this happens, of course, but of course, and that means if a box is in power cycle. So let's say the NOS is good, the NOS is there, okay, and you unplug the box and you place it somewhere else, and you do a power cycle. You're not installing the NOS now, okay. So then that's a check for the PCR measure boot. This is for installation. This is when the NOS is coming to be installed.
Okay.
Basically, Shakik, this is only for upgrade scenarios, right, in production. If it is a NPN plus one when you go in the NOS or a SMU, this is applicable.
Right.
Yeah, okay.
Right. Or there could be an instance where you have where something, a NOS gets corrupted or a certificate gets corrupted, and you have to change something. You have to reinstall it. So this is for installation processes.
So what is the difference between that, but the second and third paragraphs, installation or patch?
They're very similar. The only difference is a patch, okay, might be something that's installed on top of a NOS.
I see.
Okay.
Delta.
Next slide would be, okay, you have any more questions for that slide?
None from me.
Okay, so you want me to go to slide number 6?
You can go to 6, yeah. Reading PCRs for measure group.
Yep.
And it now dawned on me that you guys can't see my pointer because Shiva Kumar is controlling the slide. So anyway, it helps me to guide through it. So if you guys, like I say, if you have any questions, just let me know, interrupt me, and we can go back to it. Okay, so of course, the TPM, the measure boot functionality of TPM, we're using it just as it is specified in the guidelines of PCG. So during the boot process, the platform configuration registers, PCRs, which are memory locations within the TPM hardware, are updated with a digest of the firmware and the software that is going to be loaded, their configuration states, and those PCR values are sequentially hashed and chained till you finally get to the final concatenated hash chain of measurements in a log. Okay, so you have an initialization process, the one-time initialization process, for each white spot. This is occurring during the staging process. When you bare metal, you're loading the firmware and the software. Okay, then once it's staged, you have the whenever the white box is power cycled, okay, these PCR, the TPM, and the PCR values are hash chained and concatenated. Okay, now for the alert, if there's a change to the final hash, okay, then you have an alerting process where if there's a change, you will see that change, and then our systems will issue an alert. Okay, we have a whole system of sequences and protocols to mitigate the alert.
I guess, but who's performing the check of who's comparing the actual PCR final values with what's expected? I guess you have.
Okay.
And the process is called PCR attestation, right? You are basically describing the attestation process here.
Right, and I have slides following which will address each initialization, audit log, and alerting. And I answer your question in one of those slides.
Okay.
Okay. So we're good here. This is a standard TPM measure boot procedure. Here, the hashing and chaining. Next slide. Initialization.
Yep.
So you initialize, and this initialization is really to support attestation. So the TPMs, all TPMs have a unique attestation identity key. The private portion, of course, never leaves the TPM, and the public portion can be shared, just like every private public key pair. Okay, now, so what happens is the flow, the sign and store, the AIK public portion, the NAS queries the TPM to generate this public-private key pair. And it instructs the TPM to send out this public key. The NAS interfaces with the AT&T Certificate Authority, and we are building the infrastructure so that it's secure in order to facilitate this orchestration. And the AT&T Certificate Authority uses that public key to create a X509 certificate, which it signed. The NAS then retrieves that certificate and it sends it to the NAS database, okay, in this instance, for ease of use. So the NAS can easily retrieve and use the certificate for future validation. And this will be done. This is the one-time flow per box. When it's being. This is actually during the staging process as well. And of course, it'll be automated to ensure no impact for operations. Just in case this happens with another certificate in the field. And we're working with our AT&T Certificate Authority folks, and they are building up an infrastructure to facilitate us with this. And I believe they are leaning towards the CMP version 2 protocols for this sort of certificate handling and distribution and dissemination across a network.
So there is a TCG spec on the AIK provisioning. I'm just wondering, are you guys following or intend to follow TCG spec on the AIK provisioning?
Absolutely, yes. This TPM 2.0 chip, the instructions and how to create and to extract the public key. This will be all based on. This will be done by way of a TSS stack, which is recommended and issued, or at least referenced by the TCG community. Yeah, we're not going to reinvent the wheel here at all. And again, we're partnering with the vendors on this. Of course, it'll be their NAS that will be passing the instructions.
So Specifically, I was under the impression that that certificate comes back encrypted with the TPM key, right? Is that
Well,
so?
yes.
You guys are just moving blobs around into the NOS. The NOS probably doesn't know what's in that, right?
Right. The NOS, what you mean the public key that comes from the TPM?
No, the certificate that comes from the certificate authority, I think, is
Right.
encrypted with the TPM's private identity key. What's the name of that key? I forget the name.
Yeah. No, the public key that is extracted from the TPM, that public key.
Not that key. It's the public key goes to the CA.
Yes.
Along with a certificate signing request for that public key.
Yeah.
Then the CA creates a certificate, and the other piece of information that goes with that is the TPM's private key, right? The identity key, or something signed. The TPM's public key for the I forget the name. For some reason, I can't remember right now.
The EK?
Right? The EK, exactly, the endorsement key. And the CA will encrypt the certificate with the TPM endorsement key.
No, we're not using, I don't believe we're following that measure. The public key that the NOS extracts from the TPM is tied to the private key, to its private key pair, the AIK, the AIK, not necessarily the endorsement key, but I know the endorsement key is the overall hierarchy for the TPM, which governs its AIKs. We're talking specifically about the AIK, not the endorsement key.
That's right, but this protocol is designed so that you can't have a bogus TPM that's impersonating a real one. So it's really important to follow that TCG protocol, which does include sending an encrypted certificate back, encrypted with the EK, because that means only that TPM, that one unique TPM in the universe, can actually decrypt it and accept that CA. I mean, that certificate.
Right.
It really is important.
But we're not passing the certificate to the TPM.
I guess the question I have
public.
How do you establish that a given, so when your CA receives an AIK public key from a TPM, how do you establish that it is an authentic AIK and was not sent from a bogus TPM?
Right, because it's a public key, and the private portion of that public key stays with the TPM.
Isn't the AIK generated on the fly, right? Or not on the fly,
yes,
but
by the right, but it's generated by the TPM.
So
on the box.
The question is, how do you prevent some other software from generating a key pair, some other software that is not the TPM, getting the public key and asking for that public key to be signed by the CA?
So isn't that done during manufacturing?
You're saying a scenario where some other TPM, a bogus TPM, is trying to imposter another TPM.
Well, it doesn't even have to be an actual TPM. It could be some software wants to be a TPM.
It wants to pretend to be a TPM.
A software or firmware TPM. Yeah, but that other TPM has to duplicate the public key or the private key of the authentic TPM.
No.
Yeah, but I think simple solution is we need to follow guidance in the section 5.7 of AIK provisioning spec. TCG already documented. It definitely needs to be tied to EK. You can't
it needs to
do
be
without
encrypted
tying to EK. So that needs to be addressed. I don't know whether we can solve here, but please refer to section 5.7 of the TCG document. I think that I can post link and right here, but it is already solved there. You need to follow that.
Yeah, I mean, we, like I said, we have our own AT&T certificate authority. So to my understanding, we're using when we see you got to trust somebody. So we're going to trust our AT&T certificate authority, and we are not necessarily trusting the TPM, because when we take that public key and we sign it in the certificate. This is how we're validating the TPM.
Yeah, but question is that public key can come from anywhere, right? So you need to tie it to some authentic entity. You can get public key from anywhere. Maybe malicious TPM.
Right, but it can only, but this public key is paired to this private key, which never leaves a TPM.
Under what? This is a one-time provisioning flow.
Yes, yeah. This is a one-time provisioning for the certificate.
And is it done in like a controlled environment?
Yes. It's supposed to be with the AT&T. They're going to build up the AT&T infrastructure. They're going to build up a dedicated server network, which facilitates this process.
Is the TPM hardware in like a safe location when this is done, or is it like we've deployed the hardware and now we need to hook it up to the CA?
Yeah, it's in the white box, the TPM. These are chips that are mounted to the motherboard in the white box within our environment. Yes.
So can we just assume that can we just assume that AIKs are being provisioned and move on? I don't think going into the details of AIK provisioning here is going to be productive.
Okay. All right. So we'll move on and I jotted down what you mentioned about the TCG section 5.7 and we'll look at it. I mean, I'm not the only guy who is the only player for this project. So we'll dissect that and I'll have that question talked about in future presentations as they arrive. Maybe I will somehow I can maybe respond by email or have our resident experts respond by email. So for now, we'll just take it that this public key is coming from a TPM, and once it is in a certificate signed by the AT&T Certificate Authority, we are trusting this certificate, which has included this public key, private key pair, which never leaves a TPM. Okay, audit log. Next slide. See if I can work.
Yeah.
Okay, so we're at the audit logs. So during the boot and after the NAS is up and running, it will retrieve the PCR values from the TPM. Now we're going to have it retrieve the individual PCR values as well as the final concatenated hash, which will be used for our alerting process. The individual PCR values will be sent to the NOS database as well as the concatenated hash, and it'll be packaged with that certificate that we just talked about. Okay, that certificate has the public key, so then it can check and verify that this hash coming from the TPM, which is signed by the TPM using the private portion of that public key. And so the public key of the certificate validates that hash and those hashes.
I think you're describing the standard attestation mechanism here. It really helps, if anything, done differently than the attestation mechanism that is already known. I'm struggling a little bit to understand what is different here. I appreciate if you could shed some light on what parts of these are unique or different than the attestation mechanism. Maybe Ellen, you want to chime in here, but I'm having some difficulty in understanding what is different.
Okay. Yeah, I believe this is all standard stuff, except perhaps for the packaging of the certificate with the hash, the individual hashes, which will go to our collection system called agentless. But the concatenated hash will go, and we'll just talk about that on the next page. Will go to a verification procedure to check to see if that has been changed. So I'm not sure how other people do it. I know there's more than one way to do it, but querying the TPM is all standard. Yeah, it's just the checks and balances in the file system that might be done differently between different organizations. I'm not sure how another organization uses the concatenated hash. Microsoft does it differently. I do know Microsoft does it because I've been using I've been looking at Microsoft, and they have a little different procedure than we have, where they're using BitLocker. So yeah, but essentially, this is nothing new here. Now,
Question, is the verification of that hash done in the white box itself?
Yes, on a NOS database. Well, it depends. For the concatenated hash, not for the individual PCRs. They're done at the collection system, which is off the box. So let's go to the next slide. The next slide. Are you next slide, Sipa Kimura?
Not yet. No, I am.
Okay. Now you are. Okay. So that final chained hash, that's the one we're going to use to compare to see if there's been any changes to the white box. And if there's a change, we'll issue an alert via syslog. That final concatenated hash, and the hash verification process is going to occur via the NOS in the NOS database using some security measure, perhaps OpenSSL, where you can do a verification to a previous copy, because the NOS will maintain a good copy of that hash done during the staging process. And then on the next boot, power cycle, warm cycle, whatever, another PCR values and hash will be generated. And so that other hash will be compared to a golden copy. It'll be done in real time on that NOS, via the NOS, on that box. And if there's a change, then alert will be issued via syslog to the AT&T operations and support system.
Question: what if let's say I'm booting known good firmware, no problems. Firmware changes, we'll get an alert. And on subsequent boots, I'm going to keep rebooting into that into that new firmware. So I change from A to B. Will there only be one alert fired for that initial change, or will there be a fresh alert fired every time I boot into that firmware?
Yeah, every time boot is bad. Yeah, every time the boot process occurs and this hash is generated and verified, if it turns out to be not consistent with the hash that is maintained, you generate an alert. And of course, it's just it's not going to be a whole bunch of alerts. They're going to streamline it so that this is going to be a streamlined process.
Right. So am I comparing when I get a tested measurement hash? Am I comparing it to what I saw last time or the known good copy?
What you saw last time.
Okay, so then I will only receive one. If I change from A to B, I will get one alert, and then subsequent boots will not alert.
Right. Yeah. On subsequent boots, this will be good. The hash will be verified, and you will get no alert. Right.
Gotcha.
So one guy asked about the difference, how the difference in this process. I'm on the last slide now, right? You on takeaway slide?
No, not yet. You want me to go to last slide?
Yeah, you go to last slide. We can go back and forth. We can go to the last slide. And I just want to mention the one thing that we're doing differently is that we are not enabling secure boot. For sure. I mean, that would be different. I imagine most people utilizing UEFI and TPM in tandem or individually, they are probably enabling secure boot. We're not enabling secure boot because we don't want to run the risk of a box not booting up and a cluster shutting down a business because of some binary. However, we have checks and balances in place. If intrusion occurs, we have, there's always the sign and verification of software to be installed outside of our UEFI TPM protocols, and we have other file systems to handle the event of an intrusion happening.
So secure boot implies for most of us, secure boot means signature verification. I think you are still doing. What you are doing different is you have a policy of not stopping on secure signature verification failure. Is that right? I just want to make sure we're on the same page. Okay. So you are indeed using at least a part of secure boot here, which is tied to the signature verification. We are still doing signature verification, but not stopping there. Instead, you continue as we do in the measured boot, and then later on, you go and look at TPM PCRs to understand the state of the platform once it is up and running.
That's right.
I guess I thought it was only during installation or patching that we did signature verification, not every boot.
Yeah, it's not happening every boot. But the PCR concatenated hash is happening at every boot.
Right, right.
And
so I think
that's what the guy before you just described. So the way he described it was the way I presented. I hope that indicates to me that he got the gist of what I presented, because that's pretty much exactly what I was thinking, the way he described it.
So if you are not doing any signature verification, all bets may be off here, right? Basically, you may be booting completely malicious code. And you can't even trust that OS or the whatever stack you're running to provide even anything meaningful from TPM.
In the flow where you're like doing signature verification and then conditionally alerting based on whether that succeeded or failed,
right?
That sounds to be not much better than alerting on hash changes. Like if you're like the PCRs will have a measurement of the hash of the firmware, which is even more, discerning or whatever specific than a Boolean did the signature pass or fail.
Yeah, the only difference is, Jeff, somebody can take action as soon as they get alert. They can take some immediate action if they choose to, right? They don't need to wait all the way, everything to be up and running. I think sending alert intermediately or whenever you find mismatch probably could help. But yeah, I'm not sure if you're not checking signature verification on every boot is a good idea or not. I think it's going to bring in a lot of corner cases.
I guess my point was if you're doing it, if there's a change in the firmware which would have resulted in a signature failure, that change, I believe, will also result in an alert anyways because the PCRs will change.
Right.
But that's later, right? Much later. Yeah. But you may have completely malicious code, completely different code than what you think, right? Somebody can replace. If they're going to do the standard installation process, this will work. But there may be some creative ways adversaries can use to change the stack here. So as you are not checking on every boot, you won't know about it. And only time you know about the change happened is when you when you are able to go and attest, go through this verification process or attestation process based on the final PCR measurements.
Right. And I was just talking about that. And there is a file system signature verification process in place outside of this, what I presented today, that will prevent an installation of a NOS, or software. And if one were to get through that, then there's a control of a line. Then the NOS will lose control of the line card, and it will shut down, which will also generate an alert.
But is that just during update?
No, that's okay. The update process is what I described. That the protection of how I described would be if you update the NOS or SMU or upgrade. But let's just say it's out in the field and it's running fine. Everything's running fine, but an intruder was able to get in, and we're not booting the box. Okay, so that software is not just going to be loaded on that box. I mean, these routers are very very minimal. They're not really compute. They're packet forwarders. So the code that comes to these boxes is well vetted normally, and it's specific, and it's minimal. It's not much. It's not a whole lot going on with these bad boys. So But if an intruder was to get in, okay, some kind of way, and we're not power cycling the box to be able to run to go to our UEFI and measured boot procedure, that intruder is going to have to, there's going to be some signing before installation, some signing verification before installation outside of the boot process that we have in place. And if that happens, that the previous NOS is going to lose control of the box. If it's not, if it's not verified.
So I have one question.
I'm not on the box man, but there's a process for patches to prevent patches from getting onto the box outside of the boot, power cycling the boot. And what my colleagues told me is that told me is that line card was shut down and will be generated.
So what is the contribution to OCP? Is it going to be a spec that describes all this? Is it going to be software or source code, or what all is going to be part of the contribution?
Well, I don't know. We have a write-up for the section which describes pretty much this process. It doesn't go into much detail about the UEFI and so on. And even this presentation doesn't go into all the detail of how the NOS vendors and the ODM vendors in play are going to help us to facilitate this. But that write-up explains with a subtle illustration of how we intend to guard against pre-boot, firmware intrusions using the UEFI, but not enabling secure boot, but using the UEFI stores, and TPM.
Okay, so it's kind of like a white paper level description of this process. Is that kind of the gist of it?
White paper application note, probably.
Okay.
I suppose that's why we have in this presentation now, as a way to polish things up and to streamline or conform our contribution so that it fits within the OCP intentions and guidelines.
So what this looks like is just an implementation of measure boot, right? If we use the two terms, verified boot for when you stop, if you find something that is not quite right, you have some policy that you're measuring at boot. And then measure boot is you simply store the information in the TPM, and sometime later you can check it. And you make sure that before anything sensitive happens to that box, or before you share sensitive information with that box, you do the check of the PCRs, then that's how you ensure your security, right? So, but I don't see anything really new or different about what's happening here, right? It's just an implementation of measure boot. Am I missing something?
Yeah, I don't think you are. I believe this is an implementation of measure boot and UEFI. We are using UEFI stores to facilitate the certificates. Those certificates, that NOS verification that someone asked earlier, that certificate may not necessarily be stored in the NOS database. It could also be stored in the allowed space of the UEFI and be retrieved by the NOS and then do the verification. So yeah, we're not reinventing the wheel here. The only difference is, if you read the published articles regarding UEFI and TPM, rarely will you find one where you see they're not implementing secure boot, but utilizing UEFI stores. There's a custom mode. There's ways you can customize your UEFI so that you are not using secure boot. It's not a real. I don't think you'll find anyone anywhere using a TPM outside of its specifications that are listed in the PPG guidelines.
One comment I would have about this doing this, because I mean, measured boot is definitely not secure boot, but if you want to do it this way, I think it's fine. But one thing I would say is you should, if you're going to measure, if you're going to use a measured boot process, you should measure the entire contents of every non-volatile storage that you're measuring, and not just, let's say you only use half the flash. Don't measure the file that's in the flash. Measure the whole flash, because you don't want you want to be able to detect that anybody has put any sort of advanced persistent threat somewhere else in the flash or something like that. So that would be my only comment and recommendation to make it better.
I see. Yeah. Yeah, I'll take a note of that. I mean, and I'm not sure if that's not the case. Yeah, I'm not. I don't know every single PCR value from 0 to how many PCR values you have. But yeah, we do intend to measure all of the PCR values that the TPM itself is hardwired to.
So
can
I interrupt? Can I interrupt Shivkumar here? So a lot of inputs are good, great inputs are coming from this incubation committee, right? So this is the first time we are presenting from security perspective from AT&T, how we are planning to implement our security features for AT&T. So what is the next step? Are we going to get in an email like other great inputs about the flash and other things? So we'll take a look at it and then see if we can incorporate, etc. So after this call, are we going to get something combined, like feedback on what can be added to our way of implementation? Is that possible? Or do we need to come back again later on, reconvene after you give information, or what is the next step? We can address it later, but these are in my mind, so I just wanted to bring up those questions.
I suspect Stuart will capture that in the minutes of this call, right?
Yeah, I'm going to try to capture, the gist of the call.
I know a lot of things, yeah.
But I guess I'm not sure I'm going to have a crisp list of every to-do, from my notes here. But actually, this isn't the incubation committee. I mean, we're the security committee, and so I think I'm not sure exactly. Elaine may know the different roles there, of what the different committees do, but.
Yeah, we here in the security group make recommendations, but the final votes are carried out in the incubation committee, which is not us.
Okay. So since it is formed new, I was not knowing even the roles. So thank you. So, okay.
Yeah, Shivkumar, if I may wanna add, this is purely more of a UEFI based solution. Vincent is on the call, used to be part of the UEFI arc, hope still is. It might be worthwhile to run this by the UEFI committee, because secure boot was well thought through, and kind of moving away from it is something that you may want to review with them.
Yeah, and one concern I have, I think it was on slide 6. It appeared to me that the NOS was essentially checking itself, which doesn't work. And because if the NOS has been hacked in any way by some mechanism, you don't expect, then it can't check itself, because it can be modified so that it always passes or it never checks.
Especially when secure boot is not used, right? So that NAS condition is unknown at this when you are checking. Yep.
I think it comes down to like, what is the root of trust for measurement here? Because the TPM is a groovy thing to store PCRs, but it doesn't do any measurement of its own. It looks like as Elaine said, we're relying on a good chunk of code to measure itself or kick things off.
Yeah, I mean, if the NOS is changed, let's say someone was able to overcome the signing and verification, again, outside of the boot process. Someone was able to overcome signing, they were able to get some code in to change or disrupt the NOS that was there. And that NOS, the one that was there, is going to lose control of the box.
So I think what you're
No,
your root of trust relies on this other mechanism to keep the NOS from being changed.
Yeah, right. But but our root of trust is not really in the TPM. And I've had this conversation with the guys as well, and going back and forth with them.
So another way to look at this at measure boot is you need to start from a place, from a piece of code you're executing that you trust. That's what we call the root of trust. That piece of code, it doesn't need to be measured because you ensure that is authentic and it cannot be changed. That piece of code measures the next code that gets launched. Let's say this is a bootloader, and it places that information in the TPM. The bootloader executes and measures the next layer. So a layer cannot measure itself, is the point. I think that's what Elaine is getting at.
Right. Right. Oh, I see. Okay. So you're saying, yeah. So yeah, but I mean, our root of trust is more so in the alerting system and the folks in operations who are monitoring the network.
No, I mean, you have to have a root of trust in each one of those boxes to get this to work. Right? You have to start from a piece of code that is known and is protected and it follows a bunch of the requirements from the root of trust in each box.
Right. Yeah. Okay. Sure. And the way I'm using, the way that I'm referring to the conversations, I'm referencing the conversation I've had with the group about root of trust. They weren't, the way you're using it is the way I was trying to somewhat consider it. The terms itself, root of trust. But the conversation we were having was more from their vantage point about the standard, industry standard terminology of root of trust. And so that's where we got into the differences. But yeah, the golden copy, the TPM, the staging process, we have to trust the NOS vendor. We have to trust the people who designed the motherboard. We have to trust that TPM when it comes to us. Now we're not trusting a TPM. We're going to reflash the TPM. That's not in these slides, but that's more details. We're going to issue our own platform key that comes from the AT&T Certificate Authority, and we're going to create our own platform key, and we're going to issue that into the TPM. We're not replacing the endorsement key. We're replacing the platform key of a TPM, so that we know, even though we trust Infineon, we're going to put our own platform key in the TPM and our own platform key, different platform key for the UEFI stores. Yeah, you have to have some trust. You have to trust somebody.
So if I was going to look at this stuff in more detail, right, and the things that I would ask is, first of all, identifying the root of trust for measurement and the layering that happens at boot. Who writes what into which PCRs? That's number one. The other thing that came up during the meeting is during the certificate management and creation, right? There are some rules in TCG that say that the certificate authority has to send that certificate encrypted using the TPM's EK, which is the endorsement key. What that means is that the only one that can really decrypt that certificate is the TPM, not the NOS, right? Maybe there's a step where the NOS gives the TPM the certificate and then it reads it back and that kind of stuff, but that would be good to clarify. Those are the things that I think we need to clarify from this presentation.
Okay.
If you want to...
TPM.
And also, I don't know where the verification happening. Is it happening within the NOS? I thought Ellen was getting to some of that stuff, or is it outside of this box? That was not clear.
Yeah, which verification? The for the hash chain final concatenated PCR value?
Yes.
That one's happening on the NOS in the box.
And where is the comparison happening with to the last boot versus this boot PCR contents? Is it also happening at the NOS?
Yes, it's happening yes, by way of the NAS on the box.
So NAS may be already untrusted if somebody figures out a way to exploit a vulnerability and change parts of NAS. So it's almost like
I see what you're saying. Someone has to get in there and they can change that NAS, but then they have to be able to change that NAS so that it will say, okay, the hash that comes in, whatever hash that comes in, pass through.
Right.
Whatever hash that comes in, no matter the hash. But before that hash gets to, that first hash that was created is going to be, that one will be verified. And you're saying, okay, what if another hash, someone was to get into the TPM or someone get into the NAS and say just do a verification, but don't. I'm not sure how the verification process works. I'm not sure you can.
One possibility is if there's a vulnerability in the NAS, it might not even require changing the NAS. It might require just using that vulnerability to flip one bit in memory that then makes that test pass always. It's not actually changing.
Right, but the NAS uses a third party, OpenSSL or some other integrated type of cryptographic feature. I'm using OpenSSL as an example, and it's incorporating that. Maybe not OpenSSL, but some other one like OpenSSL. That's where it's doing a comparison, bit by bit.
Right, but whatever you use, assumption here is any software can be hacked, right? There are vulnerabilities in software. So you are assuming there are no vulnerabilities. In that case, what you're proposing works. But if you assume that there are going to be vulnerabilities, I think we have some serious gaps.
So rather than solving it, we're already like 12 minutes over.
Okay.
I would say there's three things that would be good to clarify, right? Root of trust of measuring and layering, right? Certificate management, and where and how the verification happens, right? If we clear those three things up, then it'll be easier for us to figure out if this is something we want to endorse or not.
And if you want to, feel free to shoot me an email. We can set up some time to just chat, whiteboard it out, go over these items.
Okay. Yeah, that's a good input. Yeah.
And the other one was certificate.
No, they're going to send an email so that we can reconvene, I guess. So based upon that input, and it need not be in this regular calls. Maybe we can have a separate call to really go over, and we can call other folks also. Experts in the area to really come and answer that. Also, we can do. So we can have a separate call, not on the OCP calls, if that works for everybody.
Yeah. And the last one was the layering, right? The layering. This is if the NAS was hacked.
Yes, I can actually put it in the chat. The three things.
Okay. No, can you send an email? Is that okay to send an email afterwards so that everybody has got a clear picture?
Yeah, that's fine. Or I can. Stuart still around?
Let one person send it, whoever it is. Yeah, send an email so that we can really follow through.
Yeah, that'll be helpful.
Okay, I'll send an email with the three questions.
Sure. Thank you.
Okay, good.
All right.
So so let me just ask the best. So next steps from here. We after we get the email, answer those questions, and then
we'll see whether how to endorse this, or maybe some other committees they may refer to some other committee. They were saying UEFI committee or something like that. So they will let us know. This committees let us know, Shakit.
All right.
Next.
Sounds good.
Yeah.
All right. Thanks very much for your time.
Okay. Thank you.
Thank you.